This video is to review curves of best fit. And one thing I want to make note of here is that it's really important that you know your shapes of your parent functions, especially your quadratic, cubic, exponential, and logarithmic. You need to be able to recognize those four shapes in order to do curves of best fit. So the example problem we're going to do is this one here. It tells you that at 1,821 feet tall, the CN Tower in Toronto, Ontario is the largest supporting structure, and you're going to drop a penny from it, and you're given this data, and we want to know where's the penny after 10.5 seconds, okay? And they don't want you to just guess, okay? We're going to use this data and figure out exactly where it would be based on this data. So what we're going to do here is you follow some very specific calculator strokes to do this, and I'm going to use the TI Inspire. If you use an 84, you should make sure that you talk to your math teacher and make sure you know how to use your specific calculator to do that. So the first thing you do is make a new document, and you're going to do list and spreadsheet. Okay, and you want to make sure that you get onto cell A, and we're going to name it based on what it was named in your problem. So this is time, and we're going to enter our data. So 0, 2, 4, 6, 8, and 10. And you want to make sure you enter it very carefully, just like it was in the problem. And then we have to title our next column, and that was distance. And so now we're going to enter the data that we had in our next column. Okay, so it was 1821, 1757, 1565, 1245, 797, and 221. After you have your data entered, the next thing you want to do on the Inspire is add a new page. So you hit the control button, the blue button on the left, and then the document button. That's how you add another page. And this time we want to add a data and statistics page. And so you're going to have these random points on your page, which means nothing to us at this point. So what we want to do is we want to click on the bottom, and we want to put our X value down here. So it was ever in our first column. So in this particular time, we wanted to put our time. So, and now it's going to realign our points. And again, this means nothing until we do the other side. So now we click, and we want our distance over here, and it moves our points again. Okay, now this is where we want to analyze our points. And you look at your data, you have to know your parent functions very well. And this looks like an upside down quadratic. So now you go to your menu, Analyze, Regression, and because it looks like an upside down quadratic, we're going to do the quadratic regression. And so you see it draws a line through the points, or what the quadratic was, and it gives us an approximate equation it gives us the equation for the regression. What's going to fit our data the closest if it is quadratic. So this is our equation, negative 16 x squared plus 0x plus 1821. So that's the piece that we use our calculator for. So it was negative 16x squared plus 0x plus 1821. We don't really need that 0x, but our calculator gave it to us. So this is the piece that we're using to answer the question. Where is the penny located after falling for a total of 10.5 seconds? So that's our time, that's our x value, that's what we're putting in for x. So negative 16 times 10.5 plus 0x, we don't have to put that in there because 0 times 10.5 is going to give us 0, plus 1821. When you plug that in, it gives you 57, And so that's the correct answer there is A. So the keys here is being able to remember the correct steps to enter the data into your calculator, and also to make sure you recognize the shape, because you can do a logarithmic regression, an exponential regression, in addition to your quadratic. So you have all those different types. You want to make sure you pick the correct one that fits your data. If you have any more questions about curves of best fit, please see your math teacher.